Hello and welcome everybody. Good morning, good evening, good afternoon, and thank you for joining the Full Stack GraphQL Book Club. This is chapter 4. Hi Will, how's it going?
Good, good. Hey, good to see everyone. Thanks for joining today. Yeah, excited to get into it.
Yeah. So yeah, we have well, this is the last chapter we are doing this side of the between the years, sort of to say. So we'll have a short little break over the next 2 weeks, just so you are aware, and we will be back in early January with chapter 5. And yeah, but today we have an exciting episode. Not only are we talking about the GraphQL library, but also we have a little raffle going on that is culminating today with a draw. So if you are watching live, on YouTube and Twitch, that is, type in !raffle and you will be added to the pot. We will draw the winner, let's say, I don't know, maybe before we do exercises today. Would that make sense, Will?
Yeah, that sounds good.
Yeah. So we have a bit of time. Everybody can get settled in. Don't yeah. Just all you need to do is really !raffle, and you should be automatically put in the pot. I see already 10 or so people have done so. So your odds are good, I would say, at the moment. So if you want to win that book that will be signing, I don't know, have you signed it already, or will you sign it live on camera?
Oh, I'll have to find one first. I was about to hold up the book that we'll be raffling off, but then I realized it's not right here anymore. All I have is my knowledge graphs book, which
Ah.
this is a good book, but not the one we're raffling today. Yeah, no, we'll personalize it. I see the box over there. I think it's across the room. So
We'll
yeah.
get it. We'll get it at least, yeah. So no, don't worry about this. So we have an interesting episode. So we covered in the early chapters. Let's maybe do, as its introduction, sort of, we covered, okay, what is GraphQL exactly? What how did it come about? And then we talked a little bit about what was the word? Now I lost the word. The not the procedures, but the
resolvers.
the resolvers. Exactly. Thank you. We talked about those a little bit. And chapter 3, we did dive in a little bit into graph databases. I mean, just to give you a sort of like a summary of what they are and what they do if you are coming freshly to this side of the world, basically, I'd say. But today we are doing the GraphQL library, which I think we alluded a little bit at, makes the work with GraphQL much more easier for everybody.
Exactly, yeah. So what we're going to do today is kind of combine some concepts from chapter 2, where we're looking at how do we build a GraphQL API. And as you said, like, we write these resolver functions. It's a lot of boilerplate code for data fetching code. And then in chapter 3, where we learned about graph databases and Neo4j and the Cypher query language. So now we're going to combine some concepts from both chapters 2 and 3 to see how we can use database integrations, and specifically the Neo4j GraphQL library, to remove a lot of the boilerplate code that we're writing in chapter 2 for data fetching, and expose some of the really cool graph concepts that we learned about in chapter 3.
Yep, exactly. So sounds interesting, sounds exciting. As ever, please, if you're watching this live, we'd like to hear your comments, your feedback. So if you are you know, have a question on what we are showing, if anything is not clear to you, then obviously say that. If you have another question or another, some kind of comment or feedback on GraphQL and how you work with it in general, if you like to share that, that's always interesting to see and to read. So I keep an eye out for any of your comments. So that would be nice if you'd like to participate in that. But yeah, here is the cover of the book. This beautiful lady. If you want to know the story behind the lady with the interesting red hat, then you need to watch chapter 1. If you haven't watched chapter 1, if you're diving in right away, then it's fine. You can stick around. But if you'd like to start from the beginning, obviously check out the YouTube playlist and go start with chapter 1, and Will explains how the lady came to be the cover girl.
It's just like a lovely, warm winter coat she has on. I
Yeah,
love that. I
mean,
love
looking
that
outside,
outfit.
I kind of think this I should be wearing this.
The pointy shoes, those look pretty uncomfortable. I'm not a fan of those. But
Yeah, probably not as winterproof. I fear they might be cold and wet quickly. So
for sure.
yeah.
Before we get into chapter 4, should we talk a little bit about the GraphQL survey that's going around?
Oh yes, that's a good reminder. Yeah, I get out the link.
Cool, you've got it. Cool, yeah. So, if you're watching this video, you're probably interested in GraphQL and Neo4j, and so Neo4j right now has put out a GraphQL survey, just kind of looking at GraphQL usage patterns, wanting to understand more about how folks are using GraphQL and with Neo4j, and also kind of looking at other services and things that could be built and integrated in the GraphQL ecosystem. So we'll drop a link to that survey in the chat. Definitely let us know how you're using GraphQL, what kind of tools you're looking for in the survey that can really help us out in how we're building integrations for GraphQL and Neo4j going forward. So please take a look at that. That would be great.
Link is in chat. I will add it to the video description on YouTube. So if you are watch this later, then you can still click there and do the survey afterwards.
Awesome, great. Cool, let's talk about chapter 4. So at the highest level, just really quick review of where we're going and where we've been. There's 3 sections, 3 parts of the book. There's the first one, which is roughly focused on the back end. Second one, which is focused more on the front end, our React application. And then part 3 has some sort of full stack considerations, like how do I deal with authorization, authentication, how do I use cloud services, these sorts of things. And so chapter 4 is the last chapter focused on the back end, so our database and GraphQL API. Talk a little bit about what we saw in chapters 1, 2, and 3, where we saw some basic techniques for building GraphQL APIs, why we build GraphQL APIs in the first place, and then an introduction to Neo4j. And today, in chapter 4, we are getting into this idea of addressing a lot of the common sort of performance and developer productivity issues that come up when we're building a GraphQL API by leveraging database integrations. And so there's a host of different tools that make it easier to build GraphQL APIs backed by databases, since this is a common pattern, right? Like a common thing that a API needs to do is fetch application data from a database. And the Neo4j GraphQL library enables building Node.js GraphQL APIs, so JavaScript GraphQL APIs, fetching data from the Neo4j Graph database. But it's a lot more than just data fetching, right? There's also really interesting authorization functionality. We can define authorization rules. We'll get into that in chapter 7. And then being able to expose some of the really powerful things we can do in a graph database with Cypher, the query language we use with Neo4j that we talked about in chapter 3, for adding custom logic to our GraphQL API. So in chapter 4, we kind of review some of the common problems that come up around the n+1 query problem, where because of the nested way that GraphQL resolvers are called, we can sometimes end up making multiple round trips to the database. That's not good. With database integrations like the Neo4j GraphQL Library, we're able to generate a single database query for any arbitrary GraphQL request. And then the database is responsible for optimizing that query, which is really powerful. And then, like we saw when we were looking at chapter 2, when we were writing these resolver functions for how to fetch data from the database, there's a lot of kind of common boilerplate code that that we can essentially remove from our GraphQL implementation if we're using the Neo4j GraphQL library. So in the book, we talk a little bit about how that fits into the ecosystem of tools, but I want to take a look at kind of the minimum viable code snippet here, because I think this shows a lot of the concepts of getting started with the Neo4j GraphQL library. So the first thing we need to do is install our dependencies for the project. So we're starting a new Node.js project, and we install the Neo4j GraphQL library, and then peer dependencies are GraphQL and the Neo4j JavaScript driver. So GraphQL, this is the JavaScript GraphQL implementation, which is required by the Neo4j GraphQL library, as well as the Neo4j JavaScript driver, which we use for connecting to Neo4j. And then we're free to use any JavaScript server implementation. Apollo server, I think, is the most widely used, so that's what we use in the book. But we could also use tools like GraphQL Yoga, any sort of JavaScript GraphQL server that we are familiar with working with. So then, we import our dependencies. So Apollo server, Neo4j JavaScript driver, and the Neo4j GraphQL library here, Neo4j GraphQL class. Then the first thing we do is we create a Neo4j driver instance. So if you've used the Neo4j JavaScript driver before, we pass our connection credentials to the driver, and that gives us a driver instance. So in this case, we need the bolt connection string. This is just pointed to a local database. If we were on Aura, we would grab that from the Aura console, and then our username and password for the database. Then we need our GraphQL type definitions. And here we've just left a placeholder. We introduced this concept of GraphQL type definitions in chapter 2 when we were talking about this idea of having a strict type system with GraphQL. The type definitions define the data available in the API, how the data is connected. We'll take a look at some type definitions in a minute, but just kind of a placeholder here for those. Then we instantiate our Neo4j GraphQL class, passing in our type definitions and the driver, so the connection to the database. And then we create a executable GraphQL schema object. And so here we're going through this process with the Neo4j GraphQL library to take those type definitions. We said this is the data that we're working with. These are the types, the objects in our API. But the Neo4j GraphQL library goes through this process of taking those type definitions and generating a GraphQL API schema that includes entry points for all of the create, read, update, and delete options for each type, and then taking into account each field on the type. So how do we basically do things like search for data? How do we add mutations for creating and deleting data? We're going to skip over mutations until I think we get into that in chapter 6. We do it in the context of a front-end application. So we'll just talk about queries. But that schema sort of augmentation process adds a lot of things that we don't need to include in our type definitions that we want to have in our API schema, and then also generates resolver functions for us. So notice here in this code snippet, nowhere have we written resolver functions that define how to actually go to the database and search for a business by name or something like that. That's all generated by the Neo4j GraphQL library, which is super powerful.
Yeah, that makes it very easy. I think sounds like it does all the I mean, not all of it, but some of the more, you know, cumbersome work takes it away.
Totally, and I think the point to reiterate here with we talk about developer productivity, and really what we mean by that is being able to get up and running as quickly as possible without sacrificing a lot of things like custom logic, configurability, these sorts of things. And so having things generated for us, that's a big piece of addressing that developer productivity aspect. So we talk a bit in the book about the generated API, how we can query for different types of information, and then we get into custom logic. But let's look at the type definitions that we're using. And this comes from chapter 2, where we were talking about this idea of graph thinking and how do we sort of create the type definitions based on business requirements. So these should look pretty familiar if you've been following along. Basically, the application that we're building in this book is a business reviews application. And so we are building up right now the API or the back end of an application that we want to be able to support things like searching for businesses, viewing user reviews, adding our own reviews, finding business recommendations, these sorts of things. And so these are the basic type definitions that we have. We've identified the entities. The types are business, user, review, and category. And so for business, business has a name, it's in a city, it has a location. And so note this is a point type. So we've added support for the native spatial points type that we have in the database. Similar here for date as well. We can use those automatically with the Neo4j GraphQL library. One thing that might not be familiar is this @relationship schema directive. So this is a GraphQL schema directive, or like an annotation in our type definitions. And this is sort of the built-in extension mechanism for GraphQL. And we add this here on any of the relationship fields. So here on business, we are adding this on the reviews field. So this is the connection between the business node in the graph and any reviews that were written by users to a certain business. And we add this relationship directive to capture the type of the relationship. So in the property graph model that we use in Neo4j, every relationship has a single type and direction. Now, we could sort of infer this from the GraphQL type definitions, but GraphQL and the property graph modeling paradigm that we use in Neo4j have different conventions for how we name things. So note here that the relationship type is all in uppercase, and where we have multiple words, we use this sort of snake case with an underscore, whereas in GraphQL, we typically use camel case. And so this allows us to be more explicit to sort of encoding the information, how we want to map that from the property graph model in Neo4j to GraphQL and sort of preserve the different conventions for the different systems, which is, I think, quite nice. So given these basic type definitions, in the rest of the chapter, we talk about how we can run this application, and we look at some of the pieces of the API that are generated for us. So for example, every type So business, user, category, and review, in this case, by default, has a query field. So each type becomes an entry point to our API. So we can search for businesses, we can search for users and reviews and so on. Now, this is configurable. So oftentimes we don't want to expose all of this data that's in the database through the API. So we use schema directives to configure that. We'll take a look in some later chapters at some of the other schema directives we use besides just relationship. That's really a common pattern here, is that we use these schema directives to configure the generated API in the with the Neo4j GraphQL library. So I won't go through all of this. We touch on sort of how do you enable debug mode, how do you see the generated database queries, and what do those look like. We talk about ordering, pagination, nested queries, and then filtering. Filtering is really powerful. So I can search for businesses by name. I can do filtering on nested fields in my selection set. So if I want to see reviews for a business that are in some threshold of
it's a little small, Will.
Oh yeah, sorry. Let's zoom in a bit. There we go. Cool. And then we talk about some of the temporal fields, like how do we work with date and date time? How do we work with spatial data? So we have latitude and longitude for all of our businesses. How do we find those near certain points? In the generated filtering in the Neo4j GraphQL library includes support for those sort of geodistance filters and so on. Then there's two more concepts that we introduce in the chapter. One is this idea of custom logic. So we saw sort of the generated API for filtering, pagination, these sorts of things, for basic data fetching. But of course, our application is going to have some custom logic. So we need to be able to add that somehow. And we do that using another schema directive called the cipher schema directive. And so this allows us to attach a cipher statement to our GraphQL type definitions. And so here for an example, we're looking at adding a recommended field on the business type. And this recommended field, this gives us an array of businesses. So the idea here is, okay, given some business that I'm looking at in the search results, if I like this business, what are other similar businesses that the user might be interested in? And so we can define that logic with a cipher statement. So here we're traversing through reviews to find other businesses that users who have reviewed the business I'm looking at. What other businesses are they reviewing? That might be a good recommendation, the sort of collaborative filtering traversal, which we looked at this in chapter 3. I think this was one of our exercises to write a cipher query to find this sort of recommendation. And so you can see how we can use that cipher statement that has some custom logic for our application. We can attach that to our GraphQL schema to expose that functionality, which is super powerful. So that's one way of adding custom logic with the Neo4j GraphQL library. The other is that we can always implement resolvers ourselves. And so if there's maybe some external system we need to integrate with, or if we're using some more complex logic than what we're able to express in Cypher, we can always just implement a resolver and pass that to the Neo4j GraphQL library when we instantiate that Neo4j GraphQL class along with our type defs and the driver connection string. This example, this is a bit contrived. We're looking at a wait time for the business. How long do I have to wait in line to go to dinner or something like that? And this is just choosing at random from this array. But I don't know, imagine we were calling out to, I don't know, some service that provides this information, or I don't know, maybe we have some function that actually calls the business, uses some, chat GPT option to do that somehow.
Yeah.
You can imagine, whatever sort of custom logic we want there. But those are the two approaches. Cipher schema directive. The benefit of the Cipher schema directive is that we have all of the power of Cipher to be able to express this logic, and it is still maintaining that single generated database query. So even though we have custom logic defined in Cipher, that custom logic, when we request that field, is included as a sort of subquery in the overall generated database query. If we're implementing resolvers ourselves, then those are going to be called sort of in addition to the generated database query that goes to Neo4j. So if we're calling out to other systems, just understand there can be some performance issues to think about there as well. So that's custom logic. And then the last big concept that we introduce is this idea of generating your type definitions from an existing database. And this is done with the introspector, which is a separate package that basically allows us to point that at a running Neo4j database that will then inspect the data in Neo4j and then generate GraphQL type definitions for us. So oftentimes we're sort of starting from defining our GraphQL type definitions, and we use that to drive the database. But there are often cases where we have an existing Neo4j database and we want to generate the GraphQL type definitions based on that existing data. So we can use this introspector package to do that, which is useful. And we'll also see some tooling that's now built on top of this introspection functionality to give us a completely no-code approach to building GraphQL APIs.
Oh, okay.
So those are the main concepts, I guess, that we wanted to talk about. The Neo4j GraphQL library, basically being able to take GraphQL type definitions to define a GraphQL API, generating a GraphQL schema for the API from those type definitions, and then at query time, generating database queries to sort of fetch the data that we want. Some ways for adding custom logic using Cipher, and then this idea of introspecting an existing Neo4j database. So the next thing we want to do is work through the exercises to see how this actually works. But I think before that, were we going to do the book raffle?
Yeah. So final chance is right now. So if you want to win a book signed by Will, well, the book, the GraphQL full stack applications book we are talking about here. If you want to win that, please, and you watch it live now, you have the chance to win this book. Type !Raffle in chat on YouTube or on Twitch. Unfortunately, it's not going to work on Facebook or on LinkedIn. So if you watch it there, well, we give you a couple more minutes to move over to YouTube or Twitch and do what you have to do there. Yeah, let's give it a few more seconds. Anybody can only type it in once. So if you typed it in already before, then you won't get a ticket, but you one ticket per participant. Yeah, do that. Maybe quickly, Will, do you have a tip for anybody that is about to write a book? Maybe book is a big endeavor, but maybe some tips on for new authors. Let's say maybe start with a blog. I don't know, maybe don't start with a book right away, but what helped you the most during your time when you were writing the book?
Oh, wow. Yeah, that's a really good question. And I was just running over to find the actual copy that we're giving away. So this is
Yeah.
what we're giving the raffle for. I will assign this personalized to the lucky winner. So here it is. Yeah, to answer your question, sort of what helped me write a book, or sort of advice for folks writing the book. That's a good one. I mean, I think a lot of it goes to your motivation and understanding your motivation for writing a book in the first place. For me, and I think this is true of teaching in general. I taught a class when I was in grad school, and this was definitely the case I noticed then. But in order to really understand something yourself, I think the best way to do that is to teach it. And so if your motivation is really to dig deep into a certain technical area to really understand a lot about it, that can be good motivation for writing a book. And so I think that would be kind of the number one thing that I would think about, is really firmly understand what's your motivation for writing the book. And if it is really to understand something or be able to share something that you've spent a big piece of your time understanding, that can be a really good motivator. I would say try to harness that and kind of remember that as you're going
Yeah.
through the process. Like what is really your motivation in the first place?
That sounds good. Cool. All right. I think anybody and everybody had the chance to type exclamation mark Raffle. It's not that complicated. So if you wanted to win, I am counting down final few seconds, and I will close the raffle. So let's do this in 3, 2, 1. Close. All right. That is done, and I'll now gonna pick a winner. And yeah, Peter Kimmel is the winner. I have it here in the back end. I done it. So Peter, and it's also posted in chat. So congratulations, Peter. Hope you will be happy with that book. I'll quickly need to figure out. I guess I didn't think this through. How to get a hold of you, but I guess we can do private private DMs on YouTube, I guess. So I'll figure this out. I'll ping you on YouTube um, for any further information that we need for you. I guess address and all that stuff. But yeah, Will, it's you can dedicate the book to Peter.
Yeah, and Peter, let us know how you want it to be signed. If you want it maybe as a gift for someone or to yourself, we can sign it to someone else as well.
Yeah.
Just let us know.
Let us know exactly. I'll ping you right away while Will gets on with the exercises.
Cool. Well, that was fun. Are we gonna do one raffle for each of the remaining live streams that we have? Is that the idea?
We could. I don't know how many books you have, but we could do it. We could do one more towards January. Maybe not right away in January beginning, because then during the next few weeks it's going to be a little bit quiet. But we could, yeah. Let's do it.
Yeah, I have several more, so I think we have enough to do at least a few more raffles. Because it's always fun to win something, right? Everybody likes to win.
True.
Cool. Okay, so we talked about the Neo4j GraphQL library, some of the main concepts. Let's see it in action using our exercises. So let's work through these and see if we can get through them. How many do we have? We've got only 3 questions. Oh yeah, piece of cake. Okay, so the first one here, so this is about the query API. And so basically, if we're following along with the code from the chapter, and this is available on GitHub. But basically what we'll end up with is this code here. And I'll zoom in a little bit. Oh yeah, and I have this. This is the landing page for the Neo4j GraphQL library, which is a good resource. This will point you to the documentation and some more resources, as well as just kind of going through some examples to explain how this works, some of the features that we talked about as well. And then also I'll link the documentation for the Neo4j GraphQL library, which is a really good resource as well. But if we're following along from the book, this is the code that we build up throughout the chapter. And we can see we have some things added to our type definition. So we talked about adding custom logic by writing a resolver. So here's our silly wait time random generator. Here we've added some cipher directive fields. We saw the recommended one and so on. But pretty similar. We have users, reviews, categories, businesses in our type definitions. And then exactly like that code snippet that we saw, we create a connection to our database and we go through the schema augmentation process and then spin up Apollo server. So let's run this. And here I'm just setting this debug environment variable to Neo4j /GraphQL:* and we talk about this in the chapter as well. That's how we enable debug mode for the Neo4j GraphQL library, so we can see the generated cipher and sort of the process that we go through in the sort of execution of a GraphQL operation. Cool, so we've got that running. It says GraphQL server is ready on localhost 4000. So let's go over there. Localhost 4000. And here we get the Apollo Studio Sandbox, which is sort of the default like debug in browser tool for querying our API. And here I've got a GraphQL query that I think I already ran, just to find all businesses by name. You can see all the businesses in our database. And this, by the way, we set this database up in chapter 3, where we were getting an introduction to Neo4j, and we loaded this data set. So if you're wondering where the data comes from, it comes from chapter 3, where we added data about businesses and users who wrote reviews of these businesses. Okay, so we've got that up and running. Let's see what GraphQL queries we're supposed to write here. And so the idea here is we want to see how we can use some of the things like the generated filtering functionality to try to answer these questions. So first off, which users have reviewed the business named Hanabi? Well, there's a few ways we could approach this. One is we can start from the business entry point. So we said each type has an entry point in the query type. So we can start by searching for Hanabi. We can see it here. So we could just traverse from the business to the reviews, and then we want to know who wrote these reviews. So we can see here, just using our autocomplete, that reviews are connected to a user, and user has a name. So this autocomplete functionality is really powerful in GraphQL. We see that in all of the GraphQL tooling powered by the introspection functionality of GraphQL. Okay, cool. So we can see, like, here's all of the businesses and all of the users that reviewed them. But let's filter just for the business named Hanabi. And so we saw and we learned in the book that there's a generated where filter. So where, this is a field argument. Oh, and I'm going to change this to inline variables so that we can keep our autocomplete. One thing I noticed about the Apollo Studio Sandbox tool is that if you use the GraphQL variables, you kind of lose some of the autocomplete, which is nice for these where filters are fairly complex objects, so we can still take advantage of that autocomplete. Okay, so we want to filter for just businesses by name, so we know the name, and so we can see all the generated filtering functionality for each field, for each field on the business type, but we know the exact name. So let's filter for Hanabi. Cool. So here's Hanabi, which is an excellent ramen restaurant in Burlingame, which is near San Mateo, very close to the Neo4j office. Been there many times. But Jenny is the only user who has reviewed Hanabi. Okay, so that was the first part. The second one, find any reviews that contain the word comfortable. What businesses are they reviewing? So because we're searching for reviews, if we, again, just start a query with the control space, we can see we have a reviews entry point. Let's start there. And then for the fields, let's just bring back the text of the review. So again, we're going to use this where field argument, and I'm going to switch to inline variables so I can still use autocomplete here. And we're searching now where the text of the review, we don't want to do an exact match, but we can see that the string comparison operators that are available in Cypher in Neo4j, so things like starts with, ends with, and contains are available. And so we want to search for, I think it was the word comfortable. So the use case here is, I'm searching for a business to go to hang out for a little bit, and I want to know one that has like comfortable seating or something like that. And you can imagine that in the web app. And so there's one review, and then I want to add some context to this. So, okay, I want to know what business this is. And this is cool. This is the public library. Great. Public library is comfortable. That's maybe a good place to go.
Although it said not comfortable.
This is true.
Oh, not many comfortable, at least. Well, okay. A few.
Yeah, good catch.
Yeah.
Okay, and the last one here, looking at the query API, which users have given no 5-star reviews? So this is a good one. So we're searching for users. So let's start with the users query field. I'll just bring back the name. And so I could look at all of the reviews and the stars that the users have given, and I could kind of look through these. And because my data set is small, I can figure this out, and I can see, okay, well, Bob's only given 4 stars, but these other users, yeah, they have at least 1 5-star review. But that's not very practical, of course, right? If I have thousands of users in here, and again, we're going to use the where filtering functionality, and I'm going to switch to inline variables so I can use the autocomplete still. And here, so previously we were filtering on fields on that type, the type where we were passing that field argument. But here, the thing we want to filter on is the review node. So review nodes are connected to the user node. And so I want the filtering applied at the user, right? But based on some value that's in the review node. And so I kind of want to filter like across this relationship, which is supported by this generated where filtering argument, which is really cool. And so I can scroll down to see it, but I can see it here. For these relationship fields, the generated filtering that I have are things like all, none, not, single, some. So these are list predicates essentially, where we're saying I want, okay, to filter for a user where all of their review nodes meet some predicate or none of them, or at least there's one or exactly one. And so in this case, we're saying where the user has written no 5-star reviews. So that sounds like that's going to be a reviews not. And what am I filtering for? Well, I'm filtering for where stars is 5. And so if we run
What's
this,
the difference between reviews not and reviews none, if there is any? Do you know?
That's a good question. So reviews not, I think that is going to be very similar, right? Let's see, does the
sounds very similar. That's
documentation
why I
say?
was wondering if there are, the others made sense to me because every had a clear explanation, but not and none seems very samey.
Oh, not is for inequality and for into one filters. So this is for the case where we have one user to one review, and in the case where we have one to many, these are using our list predicates. So in our case, it ends up being the same. Where we go here? But we could also say none as well. And I think, is it the case that was not deprecated? I feel like I had a little warning there. Is this a deprecation warning? Yeah, so not is deprecated. And so we want to use none instead. So good catch there. Yeah, we had this little squiggle. But yeah, in the documentation, it's talking about the cipher list predicate functions that these map to. So if you want to understand exactly the cipher predicate that's generated, it maps to these cipher list predicate functions. Cool. So that gives us our user Bob. Okay, on to number 2. So this says add a cipher directive field to the category type that computes the number of businesses in each category. How many businesses are in the coffee category? So if we go back to our type definitions here, we can see a few examples of the cipher directive on business. We've done something for average stars, which we could also compute using some of the built-in aggregation functionality. But let's go to our category type and tell us what we needed to call it. No, just compute the number of businesses in each category. Let's call it business count. And this is going to be an integer. And so we'll add the cipher directive that takes a statement. And so what we want to do is for the category node that we're currently resolving, we want to find out how many businesses are connected to it. And so we're going to do a match. And in these cipher directive fields, we have a special variable called this, which refers to the node that we are currently resolving, which is the category node that we're interested in. And we want to know how many businesses are connected to it, and return count B. So that should give us, I didn't misspell anything. I don't think I did. That should give us a count for each category. So I'll restart our server here. And now, if we go to the categories, we have the name of the category. We don't have that many, I think, but yeah, a handful of categories. And we now have a field called business count. Oh, I did have a typo. So all of these are 0 because the relationship I want is in category, not in business. So we have business in category. So let's restart our server. Give this a run. Cool, and we can see we've got one business, one library, breakfast, deli, coffee. This is the one we were interested in. So we could look in the list, or we could also use our where filter to say where the name of the category is coffee. And yep, we have 2 businesses.
Okay.
So this is similar to some of the aggregation functionality that is also generated as well. So things like the business aggregate we can run gives us the same information as well. So this is a good example, I guess, to illustrate some functionality that we can accomplish with the Cypher directive, but there's a lot of functionality built in as well. So the business aggregate, this is generated as part of the aggregations. So if you look in the documentation in the query API, there's a section here talking about the aggregations that are generated. So that's something to keep in mind as you're thinking about adding a Cypher directive field. Check to see is this functionality that exists already. And so this, for example, allows us to compute things like the average reviews for a business and things like that by using the built-in, or I should say by exposing the built-in aggregating functions from Cypher. Cool. That was number 2. And the last one here says create a Neo4j sandbox instance and then use the introspector package to create a GraphQL API by generating the GraphQL type definitions. And so in the code for the chapter that we looked at, and this is on the GitHub as well, is this introspect.js, and we saw this in the book where we basically use this introspector package to fetch data from a running Neo4j database, generate the type definitions, which we could then pass to the Neo4j GraphQL library. So we could write the code to do that. Let's spin up a sandbox instance. So if I go to neo4j.com/sandbox, launch free sandbox. So Neo4j sandbox, this is a way to spin up a Neo4j instance that's private to you with lots of different data sets loaded. And then there's guides with Cypher queries that walk us through how to use that. I'm going to pick the Stack Overflow data set. This is one we used for a hackathon recently. And so while that's spinning up, instead of writing the code ourselves using this introspection functionality, what I'm going to do is use a tool called the Neo4j GraphQL Toolbox. And we'll drop a link to this in the chat as well. And so Toolbox is a really neat sort of web-based tool that allows us to connect to a Neo4j instance and then leverage that introspection functionality to generate a GraphQL API by seeing what data is in that database without having to write any code at all, which is super cool. So I just need to grab my connection credentials for the sandbox instance that I just created. And then hit connect. And the first thing that'll happen is, do we want to generate type definitions? Yes, I do. Thank you very much. And so we're now interrogating the database to see what kind of data it has and generating GraphQL type definitions that matches the data in the database. And so this was the Stack Overflow database. So we can see what the graph model for that looks like. So basically we took a sample of questions from Stack Overflow. Questions have metadata like the tag, so the type of technology that it's about. Questions have an answer. Users are connected to those answers. And then questions also have comments as well. So if we look here, call db.schema.visualization. Here is the graph model that we're working with. Right, so questions are tagged by technology. Users provide an answer that answers a question. Users are asking the questions, and then we also have users who can add comments to a question. Right, so if you've used Stack Overflow before, which is a technology-focused question and answer site, this data model should look familiar. And here's the GraphQL type definition version of that graph data model. So we can see that we've added the relationship schema directive on these relationship fields to, so for example, connect answers to questions. That's how we're representing those relationships. And we can see the generated names for some of these things uses a convention of combining the relationship type plus the label of the other node and then pluralizing it. So here we have answered questions, which that actually kind of makes sense. Users provided, maybe this just be like user, something like that. But anyway, the idea here is that we can generate these type definitions and then edit them. So we can add schema directives to configure the generated API. We can remove fields. We can change the name of them. We can add cipher directive fields to add our custom logic. Once we've done that, we hit build schema, which will go through that schema generation process and now allow us to query this GraphQL API. And I'll delete this old one there. And we use the Explorer integration for graphical. So I can do things like, if I want to look for questions, I can sort of see the documentation here and just kind of click exactly the pieces I want.
That's pretty neat.
It's a really cool way, yeah, to combine sort of documentation and a query builder at the same time. So maybe we'll bring back title, and then let's just bring back the 10. Let's bring back 10 to see what sort of questions we have. Cool. So we have some Neo4j related. We can add the tag here as well, so we know what tag we're working with. Oh, right. It's not called tag. I should stick to the stick to Explorer.
It's tagged tags.
Tagged tags.
And there's tags at the bottom. I don't know which one it is. maybe this one then.
There we go.
Yeah, this one. Yeah.
So you can see where some of those generated names don't always quite make sense. So we had type question, and we can change this to just tags.
Yeah.
So now instead of tags, this is just tags. But anyway, that's the idea.
But that's easy enough, right? I mean, you can you make the perspective, you look at it in it, and then you look over it and change some things. It's I mean, if this is the only thing you need to do and clear out some names that are a little bit confusing, then I think it's super easy already in terms of comparing it to writing it all yourself.
Totally, yeah. Going back to that idea of developer productivity, right? It's kind of removing the things where, as a developer, I don't really have any competitive advantage in sort of skeleting out the boilerplate for a Node.js GraphQL API. Like the domain is really where I have my competitive advantage. So I want to focus on the domain for my app. So I kind of remove the need to think about how to sort of deal with a lot of boilerplate code. And the idea here is just to be able to get up and running, test out, and develop my GraphQL API. And then once I've built out the type definitions, oftentimes we're going to do a lot of configuration. We're going to add some Cypher directive fields for the custom logic. Once I have that, then I can take those type definitions into into a project like this, where I'm running my GraphQL API and sort of work with that app. But you can see, so earlier we mentioned that survey that the GraphQL folks at Neo4j are interested in collecting your input. And there's actually a link to that survey here at the top, which says wanted to manage your GraphQL API. That's kind of what that survey is getting at, is like, okay, we have this GraphQL toolbox tool, so I can provision test a GraphQL API on a Neo4j database. The next step is sort of to deploy that somewhere. And so that's what the survey that we mentioned earlier is really getting at. Maybe we can drop another link to that in the chat if folks didn't see that. But really, like what do you think the next step should be? Like, would you be interested in having some managed service that then allows you to go from a tool like GraphQL Toolbox, where we're sort of visually defining and testing our API? Could I then like click a button and have that provisioned in the cloud somewhere connected to Aura? Is that something that folks would be interested in? So if that sounds appealing to you, or even if not, let us know in that survey. That would be really helpful as we're sort of trying to design the next phase of Neo4j GraphQL tooling.
Yeah, that would be really good. Always looking out for feedback. The the GraphQL team in particular is very active on our community as well. So if you have any feedback, any comments, go to our Discord server or go to the community page and let us know. So the team is very likely to answer directly if you have a question, or at least add your comment in consideration for a future release. So would be great to see how you are working with it, what you're doing, what your struggles are, or maybe what your success is also. I mean, it's also great to say, hey, this helped me do this and that, and it's great now, and I'm really happy with it. I mean, it's not always about the bad stuff. It's the good stuff is also appreciated.
Totally, absolutely. Cool. Well, that's all the exercises. We got through all those. We talked about the main concepts from chapter 4, which is introducing the Neo4j GraphQL library. And this is the end of part 1 of the book, focused on the back end. When we pick up again in January after the new year, we're going to be looking at chapter 5, which is all about getting started with React. So we're going to start building out the front end of our application. Chapter 5, we're going to have a sort of an introduction to React. And then in chapter 6, we talk about data fetching in React using Apollo client. So those two chapters, 5 and 6, make up the building the front end piece before we get into more advanced things like deploying cloud services and that sort of stuff.
Okay. Oh, that's cool. So yeah, like Will said, we will be back on the 5th of January, same time as today, 6 p.m. Central European time, 5 p.m. GMT, and I don't know what time that is in, what time was it? Well, you see it in the events. If you go to neo4j.com/events and so look for GraphQL, it automatically adjusts to wherever you are. So it should be it should say your time when you look at that. So 5th of November, of course, yeah, 5th of January, 2023. Believe it or not, we will be back with the next episode, so chapter 5, and this was not the last stream this year. So there's one more coming. Not particularly on GraphQL though. One more coming on Monday. We have Michael and I will have a special guest, Pierre, our colleague Pierre Haftermeyer, who is doing currently the Advent of Code challenge with Cypher. So he will show us how he solved a couple of the challenges running Cypher only, and maybe a couple of his, some best practices, some tips and tricks, and also some fun ones that were. And I saw a couple of them, and last time we did this also. Some of them usually are very graphy. So then where other people write like, this much of code, you use one line of Cypher and you're done with it. But on the other side, sometimes it's a bit more complicated to get around using Cypher because it's not a full programming developing language, so it's just a database query language. So you have to be a bit creative to find a way around some of these challenges. But it's fun, and yeah, that's the page. So that's on Monday, 19th December, and yeah. That's that. Thank you, John. I hope, Peter, I hope you saw, congratulations again. I hope you saw my message. I couldn't reach you directly because your YouTube account does not have any things, but I see your I see your email reached me already, so that's great. So I'll get in touch and we sort out all the logistics for the book. I'm not sure it will arrive by Christmas, so maybe you have to be a bit more patient, but we'll do our best so it gets to you as soon as it can. And yeah, one more question, maybe, Will. Let's do it. V2 Belleville asks, are the conditions under which a REST API would be more appropriate than GraphQL to expose a Neo4j database? Has Neo4j a similar library to write REST API? Write to, or write, yeah, use a REST API.
Yeah, that's a great question. The choice of sort of how to build that API layer depends on a lot of things. What you're trying to accomplish. I talk a lot about GraphQL. I think there's a lot of value in GraphQL. I think especially when you're building web applications specifically. There's a lot of value for GraphQL, but it's not always the right tool. There's a lot of sort of built-in functionality you can get out of the box with the Neo4j GraphQL library. But there are, of course, cases where using a REST API makes a lot of sense. One pattern that I really like for sort of simple endpoints is using the map projection functionality in Cypher to be able to return JSON data essentially from a Cypher statement. And so if I'm building something like, I don't know, an Express app, or we do this with like Cloudflare workers as well. For each endpoint, I basically write a Cypher statement and then use the map projection functionality in Cypher to return JSON data essentially from that cipher statement. That can be like a really clean approach. So in terms of what libraries are out there to enable building REST APIs, you know, there's a lot of different functionality depending on the ecosystem. Spring Data Neo4j is, if you're using Spring Framework and Spring Boot, that's a way to go in the Java ecosystem. The approach I was talking about with sort of using a cipher statement to return a JSON payload. You can use any of the native Neo4j drivers in different languages combined with whatever web server. So in the JavaScript ecosystem, that might be something like Express. There are other more lightweight sort of packages for doing that. So yeah, I think it just kind of depends on what language and what sort of ecosystem you want to work in.
Okay, cool. So yeah, I think that brings us to the end of this show. Thank you all for watching. Thank you for participating. Thank you, Will, for presenting, obviously, and for showing us the solutions to the exercises. So I think that was, again, is great. The repository is available, so you can do it on your own as well. And now you have like a commented guide to the exercises if you are stuck with something, and hopefully that helps. Yeah, thank you all. I wish you a good rest of your day. Hope to see you on Monday again for the final stream this year. And yeah, take care and see you soon. Bye.
Cool. Bye, folks. Cheers.